Welcome to the Supply Geek podcast, the show that turns shipping containers and glossy corporate advertising into real stories worth sharing. I'm your host, Ben Thornton-Jones, and whether you're a supply chain geek like me, a conscious consumer, or just someone who's always wondered how the toothpaste tube ends up in your bathroom cabinet, you are in the right place. Each episode, we unpack the hidden stories behind the stuff we use and the things we do every day, from palm oil plantations to the milk supply chain, from cargo ships to carbon emissions. We're not just about moving goods here, we are here to move minds. So, grab your map of the world, adjust your safety vest of skepticism, and let's dive into the weird and wonderful world of supply chains. Let's get geeky. So my guest today and top toothpaste and packaging geek is Joe Muscat. Joe, welcome to the podcast. We've worked together many years, so it's great to have you involved in this podcast. And I honestly, Joe, I couldn't think of a better person to kick off our very first episode focused on packaging, in fact, than yourself. As you know, we've talked through in this series so far many materials that go into the products that people consume, but we can't forget that for those products to make it to consumers' front doors, they need to be packaged, they need to be transited, and a lot of times they need to be used by consumers, which packaging also supports. So great to talk about this one today and focus on, there's many different packaging types, but toothpaste tubes is what we're going to double down on. But I'm sure what we'll get into as well is a bit of knowledge and information on plastics, how they're made, and packaging a bit more in general. So really looking forward to this one, and thank you again for being part of it. But before we get into that, we like to find out a bit about our guests, your career, etc. So first, tell us a little bit about yourself and why you know more than most people about toothpaste and packaging.
Lovely. Well, look, first of all, thanks for having me on, Ben. So I'm Joe. My background really is I'm a chemist. So from when I was, a young kid, I was always fascinated by how things are made, how they're put together. And for me, science is, chemistry is the science of stuff. Everything is made of chemicals, the air you breathe, the water you drink, and the stuff that you use every day. The screen I'm talking to you right now is made of chemicals. So for me, that kind of got me into studying chemistry for my first degree, did a PhD in chemistry, had the opportunity to work abroad for a few years in Australia, looking at how do we use chemistry to mine materials more efficiently and more effectively. And then eventually I ended up settling on a career in consumer goods products. I was always very fascinated by the stuff that people buy, the way that people interact with materials, with products. And I joined Unilever in 2002, which was a fabulous company, really kind of focused on delivering fantastic products to people, but also doing it in a sustainable way. And then that got me thinking about how do we create products and how do we get them used in such a way that we sort of minimize the carbon, we minimize the waste, we minimize the negative impacts of using products, because everything we do has an impact. Fabulous time in Unilever for about 19 years, then came to join GSK, where you and I first met, looking at how we set up our packaging sustainability strategy for the company and for what subsequently became Haleon, which was a consumer healthcare spin out from GSK. And really my role was focused very much around, we produce medicines, toothpaste, vitamins, in packaging. How do we develop that packaging in such a way that it's more sustainable? And what we typically mean by that is uses less fossil-based materials, and you can recycle and do something with the packaging at the end of it. And as well as that, there was a fair amount of work around interest in terms of how do we design the next generation of products to be more sustainable. So that's fabulous. So I've been doing that for about the last 4.5 years. Shortly due to make a change, so I'll be announcing that in the next kind of couple of weeks, but it's been a fantastic time. Outside of work, married to Helen, 2 girls, 12 and 15. They are probably my biggest carbon contributors right now. I don't know if you've done a piece on fast fashion yet.
Oh, it's in the list.
I can get you a couple of consumers to talk to you about why you need 50 different outfits. for
Yes,
every occasion.
yes, it's absolutely on the list. So yeah, I think that'll be a really interesting one for lots of people. And I start to see it with my own son as well, but maybe not quite as much as two verging on teenage daughters. So fantastic. And Joe, yeah, just to say that I think you've done a fantastic job in what you do. You know, you'll go on to do great things. But yeah, even you called out there, look, today we're going to focus in because it's good to also focus on one product because there's so many different packaging types, but you've got that experience right across the board. But today we are going to focus on toothpaste tubes because it's something synonymous in everybody's lives. It would be a worry if I would say if no one has a toothpaste tube in their house, perhaps they're using a funny format or they're just not brushing their teeth, which is not a good idea. But yes, we're going to focus on that. And I think it's going to be a really interesting conversation to talk about that packaging type and some of the challenges, but also some of the solutions that we have around that and the work that you've done. So let's get into the conversation. A bit of history on toothpaste that I was looking into, which actually blew my mind. So, toothpaste has been used for literally thousands of years, which I didn't quite appreciate. Apparently, 5000 BC, it was being used by the Egyptians, very chalky material that they would use mixed with mint and other materials, which is very, very interesting that a few of those things hasn't changed, but it was a powder. Even information to say that it was used by the ancient Greeks and the Romans as well. So this is something that's been used for a long time, and further the Chinese dynasties as well. So it's been around for a long, long time. However, in a powder or a jar form, but we really want to focus on toothpaste tubes. And apparently toothpaste tubes were first launched towards the end of the 1800s by Colgate. I got this from Colgate's website, so we might need to double check on that, but I'm sure they were very, very active in that space. So that is the first time that we saw it coming into a tube format, which again is a long, long time ago. We're talking nearing on 150 years, but I'm sure the very first toothpaste tube has changed a lot in that time, but it's something that's been around for a long, long time. And something that is multiple billions of tubes used every year. Again, researching this, I think I found that numbers suggest around 20 billion toothpaste tubes are produced and therefore consumed every single year. Huge amount. Of course, servicing the global population and everyone generally in the world, a high proportion are going to be using toothpaste and brushing their teeth every day. So big industry, big product used throughout the world. So a great one for us to talk about. So let's start to get into that and for people to understand, because from my point of view, toothpaste tubes, I'm going to make the assumption, well, I always think they're just plastic, right? You have a plastic cap and the tube, but maybe you can just start the conversation and let us into some of the geekiness around what is a toothpaste tube? How is it made? What it's made from? It would be great to start to understand that.
Yeah, brilliant. I mean, look, I think the kind of whole history of a toothpaste tube has kind of followed the development of science, like as you alluded to in the 19th century. I mean, a lot of it really, toothpaste used to come like in jars and in herbs and stuff that you'd rub onto your mouth. And the big unlock actually came nothing to do with plastics, but it came because of the discovery and subsequent kind of commercialization of aluminium. People worked out how they could make aluminium in a cost-effective way. I mean, there's evidence in there that when it was first discovered, it was more valuable than gold or platinum. People used to make aluminium jewelry, and then we found a way of being able to make it very cost effectively. People started finding other uses, and one of those uses was you can roll a very, very thin piece of aluminium and turn it into a sheet, and then roll the sheet up on itself and seal it. Put a couple of ends on there, and then you've got a tube. So people started using that to package things that you wanted to be able to dispense in a pretty careful way without sticking your fingers in. So actually, one of the first uses for tubes was for paint. So paint, people could buy paint in a tube, much more convenient than trying to dip your brush in a jar. You could put it straight onto an easel and paint from that. And then the story of how that jumped onto toothpaste is a little bit murky depending on who you talk to. So I think there's some stuff on the Colgate website about how they invented the tube, but also Johnson and Johnson claimed to have also developed the toothpaste tube or launched the first toothpaste packaged in a tube. They don't make that brand anymore. But anyway, sometimes it was the late 19th century. number of people very close to each other came up with the idea of putting a thick paste of a product that can clean your teeth inside a metal tube that you could squeeze out. And the older ones among us will remember the old aluminium tubes where you'd sort of roll it up and depending on how you used it, I mean, as kids, you'd always squeeze from the middle of the tube. So you'd have like a whole lot of stuff at one end of the tube, but you couldn't get out. Then you'd learn to roll it right from the end onwards so that you could get all the product up. Sometimes it would crack and it would dispense. If you get more toothpaste coming out than you want. So it wasn't a great, easy thing to use. So then somebody had the smart idea of making a tube out of plastic and aluminium material, a mixture of two materials, which we call a composite. And the idea was plastic is flexible. So if you squeeze plastic, it kind of recovers back to its shape. You combine that with aluminium, which is a fantastic, what we call barrier material. It basically keeps products fresh. It prevents oxygen coming into the product. It prevents moisture coming in. So it keeps the stuff you're trying to use in a kind of hygienic, fresh form. So people then basically started selling from a kind of late 70s, early 80s, what we call composite tubes, aluminium plastic tubes. And a toothpaste tube is actually made of a whole lot of different layers. It's a sandwich material. So you'd have a 2-3 layers of plastic, then you'd have a layer of aluminium in the middle, then you'd have another 2 or 3 layers of plastic outside that, and then you put the printing onto it, you put the cap, seal it at one end, and so on. And that was basically the sort of standard tube that was around for about 35, 40 years. The trouble with that is that if you want to try and recycle the plastic, it's very, very difficult to separate the aluminium layer from the plastic layer. They're bonded together. And we'll come to this in a minute, but if you want to try and recycle materials, whether you want to recycle the aluminium or you want to recycle the plastic, you want to be able to get the different materials as easily separatable as you can. So you can recycle Coke cans, can to can, 60 days, because it's nearly all aluminium. You can recycle a plastic water bottle like this one pretty easily because it's all plastic. For those of you who are listening to this, it's just any water bottle, any transparent water bottle, you can recycle it. So the trick with tubes was finding a way to be able to separate the aluminium from the plastic. And pretty quickly, we found that you can't do it easily. It's theoretically possible, but very expensive, very hard to do. So the industry, and again, who was the first? Don't know. Colgate would say they were the first in the kind of the late 90s, 2018, 2019-ish. I claimed it. GSK announced in 2021, Unilever around the same time. Basically, sometime around 2020, everyone started working on how to launch toothpaste tubes made of one type of plastic, high density polyethylene. And there was a fair amount of work that had been done to kind of say, look, can this, by removing the aluminium layer, can you still keep the product fresh? And all that background work had been done, and everyone was pretty confident they could do it. And that's what kicked it off. Everyone said, right, we're now going to start switching to what we call monomaterial, single material toothpaste tubes made out of one type of plastic without the aluminium. Lots and lots of testing was done to check that the product stayed fresh. I mean, typically you'd fill some of these tubes, put them in a container and store them for a period of time, months, sometimes years, sometimes at normal temperature, like 20, 25 degrees, sometimes at elevated temperature, just to check that the product stayed as fresh as it did with an aluminium plastic tube. The bottom line is we discovered that these tubes work, and GSK, Haleon, Colgate, Unilever, P&G, the whole industry said, right, we're now shifting to these tubes. It began in earnest from about 2021. Now we're in back end, nearly in 26, in some of the biggest markets in the world, so the North America and Europe. Nearly every toothpaste tube that you see out there is now made of a monomaterial, high-density polyethylene. So it's one type of plastic, but then you don't need to separate aluminium from it because there isn't any, and you can now recycle it. And to your point, of the 20 billion tubes that are made every year, depending on the market, but typically upwards of 90% of all toothpaste tubes are now made of a new material. So we're there. It's a little bit of mopping up to do, but it's been quite a long journey. Lots of development and then lots of testing and then lots of time to roll them out.
Wow, fantastic. Thank you for taking us through that. What a journey it's been for toothpaste tubes. I mean, I am old enough to remember the metal ones, and it makes me think. Actually, I was cooking yesterday, and I used some tomato puree, which
Yep.
still comes in the metal tube, and it made me
Darn it.
think that's one of the few things I can think of that's still in that sort of metal style. It's very stiff. To get the
Yeah.
last bits out, you start to roll the end. Very different to the toothpaste tubes that we had now, and very aware that everyone wants to claim the first to do anything. But I think what you called out there is who cares who did it. I mean, the fact that we've moved from toothpaste tubes that were not able to be recycled to now, like you say, in many markets, up to 90% are in a format that maybe people wouldn't have even noticed that some change was happening, but great to know that so many are now in a format that can be recycled because, of course, there's value in these things, and stuff going to landfill and not being reused is a real challenge for everybody. So really, really fantastic to understand. Joe, I think what would be interesting, you talked there about how, you know, a toothpaste tube isn't just a bit of plastic. It is multiple layers, a couple of different plastics, then an aluminium layer, which has obviously now been removed to make a recyclable version. Maybe we could just get a crash course in plastics for a second. And don't worry about getting geeky. This is a geeky podcast, so just you can really go for it. But it would be great to understand. I think there's huge confusion. I get confused myself, having worked in bottled water industry previously and things like PET versus PVC. People have heard of all these different times. Plastic is quite a broad banner of many different things. Perhaps you could just give us a whistle stop tour of the different types of plastics, their different formats, what they're used in, and maybe also how plastic's made and what it's made from.
Yeah. So look, the definition of plastics is incredibly broad. And I mean, if you search back, what are the earliest plastics when we were invented, you get an answer almost as wide as the one that you saw for the toothpaste. I mean, some of the earliest plastics that have been used have actually been rubber. So people have been using rubber for thousands and thousands of years, and rubber is a plastic. The definition of a plastic is a material that you can mold and you can form, and you can do that with rubber. Yeah. Natural polymers, natural plastics. And they were around for thousands of years. And then people started modifying them. They would take animal derived materials like ivory and modify them and do all sorts of interesting chemistry with them. But they're all starting with a natural source of a material. Really little bits and pieces were happening up until the 19th century. And big explosion of science, particularly chemistry kicked off. I mean, the 19th century was a century of chemistry. We went from living almost like very, very different lives to, at the end of the 19th century, you'd actually recognize a lot of the things that you see today because of chemistry. So what basically happened is people started finding ways of modifying some of these materials. And one of the earliest inventors in this place was a guy called Parks, who basically found that he could modify cellulose, so the material that wood is made from, and make it into celluloid, a plastic. People then took the celluloid and started using it to make films for photography, for cinematography. So when you talk about celluloid, that's where it came from. It came from cellulose that was modified. That was in the kind of 1860s, 1870s. And then, lots of other little developments were happening, but still natural based materials modified. One of the first big changes was when somebody actually took two synthetic chemicals and combined them together to make a synthetic plastic. A lot of people claim to be the father of plastics, but the first person to really make a synthetic plastic using two different synthetic molecules was Leo Baekeland. He was basically a chemist who developed a material, plastic, that he gave his name to. You might have heard of Bakelite, invented in 1907. Again, the point about who was first, I mean, he filed his patent a day before another person filed a patent for a very similar material. And Bakelite from 1907 onwards was the first mass-produced synthetic plastic, so made from synthetic materials. And you might see in some antiques and some kind of old historical TV programs and other, consumables, old products from like the turn of the century, the 20th century, materials made out of Bakelite. So things like old phones were made of this kind of big, heavy-looking set plastic. It was Bakelite. They used that plastic to make things like buttons for soldiers' uniforms because it was a new material. It was light, it was strong, and it was new. It was novel. And Bakelite was really one of the key materials that meant that because you could heat it, you could form it, you could mold it, you didn't then have to start to carve out a telephone headpiece. You didn't have to make a phone out of metal to shape it. You could mold it in a plastic, and that gave you the first kind of moldable components, and big invention. And then things kind of progressed from then onwards. I mean, towards the late 20s, early 30s, people then started discovering other types of materials, polyvinyl chloride in the US. ICI ended up accidentally discovering polyethylene, which is the most widely used plastic we have today. I mean, they were doing experiments where they were taking what we call a feedstock, a base molecule we used to make polyethylene, ethylene, and they had it in a high pressure pipe. And they were mixing with some of the materials. And then when they cleaned out the pipes, they found this weird waxy material, which they then analyzed. And what we found was it was a lot of little chains of a molecule called ethene. So lots of little chains put together in a line that basically made this material stretchy. You could melt it, you could form it, you could do all sorts of things out of it. And they named it polyethylene. Poly comes from the Greek for lots or many. Ethylene was the base molecule. That really kind of sparked the whole, big revolution around materials from kind of 1933 onwards. First discovered in northwest of England, actually in a place called Winwick, which is 8 miles from where I'm sat today by ICI. And people then started mixing lots of different materials, lots of different chemicals. You could do a lot of stuff with plastics, and the profusion of different materials came along. So PVC had been discovered just before that. It's basically very similar material to polyethylene, but with chlorine atoms instead of hydrogen. In some places, people then started looking at materials like polyethylene terephthalate, which is a material used in plastic bottles. They did all sorts of other modifications. So some of the plastics that you hear, PET, polyethylene terephthalate, HDPE, high density polyethylene, PVC, polyvinyl chloride, they're all materials that came around the kind of back end of the during the 1930s, and they kind of accelerated during the war. And, when this class of material was discovered, it was amazing because you had a material that basically didn't break down. Right, it didn't corrode, it didn't rust, it didn't break down. It was waterproof. It provided, it was kind of airtight. It was incredibly strong, incredibly light, incredibly cheap. So people found then that you could put things in them. You can't. It's not just about making things like telephones or buttons for soldiers' uniforms. You could make jars, bottles, cans, containers. The fact that plastic is so strong and so light meant that to package a given amount of a material in a plastic needs massively less amount of material than it would do if you're making it out of glass or paper or metal. I think the numbers are something like to take a plastic water bottle and make it out of glass, you need over 10 times as much glass to be able to do that. And that's because it's so strong and so resistant. And because it's plastic by definition, it's moldable, it's bendy, it's flexible, it doesn't shatter, so it's strong.
Yeah.
So a fantastic material. That unlocked the whole kind of consumer goods revolution that you saw in the 1950s, because now you could make stuff in one site, one factory, and you could ship it all around the world, comfortable in the knowledge that the material is going to be fresh, it's going to be in a state that it lets the factory, it would have a shelf life of 2, 3, 4 years. And even you could transport food, you could transport cosmetics, you could transport toothpaste, you could move things all around the world. So that really kind of unlocked the kind of consumer boom. But I think but then, the interesting thing came, we used a lot of plastic, and because it was so fantastic as a material, more and more plastic started being used, more and more applications started being used. And we hadn't quite thought through when we started using it, what are we going to do at the end? So all of a sudden, you've got all of this plastic that's getting used and it's getting thrown in the bin. Nobody was worried about it because the biggest strengths that plastic had then became its Achilles heels because it's strong. So, and it doesn't decompose and it doesn't break. So it persists in nature for many, many, many years. It's very, very cheap. So it's very difficult to persuade someone to collect it. If your packaging was made of gold, there would be no gold pollution. Everybody would be collecting. Because plastic is so cheap, it's almost not worth economically to collect a lot of it. And so you put all of these factors together, fantastic material, incredibly cheap, lots of uses, very, very durable. And all of a sudden, we found ourselves from like, the 70s and 80s onwards, started thinking, hang on, we're starting to accumulate large amounts of plastic in the environment. And that's when we started thinking a lot more about how do we find ways of collecting the plastic and recycling it and processing it to make new things. And that's when we started to think about, well, are we designing our products such that they can be separated? So, um, again, coming back to what I said earlier about the tube, the original plastic aluminium tubes, they were composites because you take the best properties of one material, a plastic, combine them with the best properties of another material like aluminium, put them together, you get a composite, and you get the best of both worlds. People were doing that with plastics. They'd take a particular type of plastic, put additives, put different sandwich layers, put different materials together so you can get all the good bits of different materials. It's almost like breeding plants. You'd be putting all the different best together, which then meant that at the end of it, if you want to separate it, you've got a nightmare. You've got a chemical soup that you've got to try and separate. That makes it really, really hard. We saw a shift from like the is and the noughties to say, how do we then redesign our packaging to make it easier to recycle, avoid using lots of different types of materials where we can. The science of making plastic had improved. So monomaterial plastics from 30 years ago could do certain things, but the new ones can do more because we can synthesize it better. We can control their structure better. We can do a lot of clever things with how they're put together. And that's been the move for the last 10, 20 years to really look at packaging uses and look at how do we simplify it. And the tube was one example. It's still a sandwich material. In your toothpaste tube, if you cut it open, there's still 7 layers of plastic in there.
Oh, wow.
But it's 7 layers of plastic, whereas before aluminium and so on in there. And that's really been the journey to how do we design a plastic so that it can be recycled. Then you come to the waste industry, the recycling industry. And again, recycling started to really become much more of a kind of thing that you saw as a householder, probably from like the sort of 40s and 50s onwards. That explosion of consumer goods where people could buy products that have been pre-packaged in a container, whether it be a glass bottle, a jar, or a plastic container, that really shifted in the 50s. Historically, people will buy things in refillable containers. Your milk bottle. The milkman will come, they deliver your milk bottle, you'd use it, you leave it outside, they're collecting. And the same sort of thing would happen for lots of other types of materials that you buy. Food. You'd buy it in loose and you'd put it in a bag and you'd store it until you needed to use it. Well, when plastics came along and materials like aluminium and glass also became cheaper, it became much more cost effective and actually easier just to make stuff that's single use. You package a product and you give it to consumers. And plastics had the biggest challenges of all because it's so much cheaper and more commonly used than aluminium or glass. But every type of material faced that. So in the 50s, people started thinking, hang on, there's a lot of stuff coming from households now. We need to have a mechanism for not just collecting rubbish, but collecting some of these things and recycling.
Yeah.
And the most valuable materials, metals, they started to be recycled first. We'd already got into the mindset a little bit of recycling metals because of the war. There was a big push to try and get iron and steel and other metals to kind of make munitions during the war. Donate your metal pans. It was one of the campaigns that they had. That then started happening for cans and for other products in the 50s and the 60s. And it kind of went a little bit like where the money is. So the most valuable materials are your metal cans. Then it would be things like certain types of glass where it's very commonly available. Then it became plastics. Paper was always kind of somewhere in the middle. So you had the packaging producers, companies that make products, sort of working out how do they simplify their products. You had the recycling industry saying, right, well, we've milked a lot of the value now in metals. What's the next thing to go after? What's the next thing to go after? The two kind of worked, reasonably closely together, not perfectly in sync. But there's always a little bit of a delay between when you make a package that can be recycled to the point where the industry can then take it and recycle it. But the two kind of go hand in hand. And we're at a stage now where, you see a lot of the figures out there, like something like 9 or 10% of the plastics made are recycled. The other 90% are either landfilled or incinerated. That's a horrific figure. But that's starting to move, and it's been moving, and it's a global figure. So in the UK, depending on the type of plastic that you're using, we're getting 50, 60% of certain types of plastic being recycled, much less for other types, but it's moving.
Yeah.
And
Well, fantastic. Yeah, it's so interesting to understand the history and, and you touch on there a couple of points just to raise. I mean, one thing is to say that, plastics, quite rightly, in a lot of ways, has been its own downfall and has got a very bad name. But we can't forget the incredible things that we can do and what we have in our society because of plastics. You could get into medical advances, you could get into, you know, aeroplanes, air travel. You could get into, the fact that food can last longer, can, travel to our homes, all sorts of different things. As I sit here, I look around at my laptop casing and this microphone and the glasses that I have that I'm wearing, so many things made from plastics that just would be unfathomable
And
previously in terms of what we were doing. So it is such a fantastic material. But you mentioned there a couple of times as well the economics of it as well. A
and
very,
and
very
lots of
cheap
people actually
material.
rely on plastic to keep them alive. I mean, I know people that have had stents put inside their arteries. These are made of
Mm,
plastic, so
yeah.
it's actually keeping them alive. And to your point, I mean, I think everything that we do right now, we're using plastics in one form or another. And if we're serious about trying to get to net zero, then actually, because plastics are so light and so strong, they are the lowest carbon footprint material we have out there if you want to be manufacturing materials. How do you make a car more carbon efficient? Well, you make it lighter. How do you make it lighter?
Mm,
Well, you replace the metals with the plastics where you can.
mm,
It's that little bit of it's almost like a paradox in a way. We worry a lot about plastic, but actually, for a lot of instances, the solution is plastic. And
mm,
I mean, I'll give you one example. You've probably heard of this, but maybe some of your listeners haven't. We talk a little bit about things like food being overpackaged in plastics, but actually, there's a famous example of the cucumber. If you buy a cucumber loose and it's not wrapped in any a plastic at all, it could sit in your fridge for 3, 4, 5, 6, maybe a week. A few days up to about a week. If you buy a cucumber that's shrink wrapped in plastic, all of a sudden it goes from 3 or 4 days, maybe a little bit longer, to 2, 3, 4 weeks,
mhm,
depending on how you store it. So, and the same thing applies for other fruit. There's been a lot of experiments that have been done in the supermarkets where they've taken the plastic out of certain types of fruit and veg. And what we found is food spoils much faster. You get a lot of food
mm,
get lost in the supply chain before it reaches the supermarket. And then when people buy it and they keep it at home, it goes off quicker. So
mm,
imagine buying a loaf of bread in a paper bag. You get maybe a day out of it before it goes hard. You buy it
yeah.
in a plastic bag, you get a week out of it. So it's
Mhm,
and carbon is still the whole thing about carbon is it all depends on mass of stuff. How much stuff are you putting out there? So if
yeah.
you're wasting a loaf of bread, there's no point trying to save half a gram off of a material somewhere else if you're losing 700, 800 grams of bread because it goes off in a day.
Yeah, absolutely. It's a great point to make because I think it's, like I say, it gets such bad press for the plastics problem and, quite rightly, but I think some people forget the huge benefits and we need to get to a place, as you've described, where I think innovation in the plastics that we're using, these mono materials like you talked about with the toothpaste tube, and then investment. I think we'll get onto this topic later on, investment and development of the recycling industry as well. We've got to move towards that more circular model because, there is not going to be a world without plastics. That's just not going to happen. So if we have a world with plastics, we need a way for it to be recycled, be reused where possible, and still gain the huge benefits from it. This is a supply chain podcast, so I wanted to get into the supply chain now and just explain to people, can you take us through the standard supply chain, simple level of the plastics industry? I'm thinking from what is the base raw material or materials that go into it? What process does it go through? And I'm talking virgin here, virgin meaning a brand new plastic as opposed to something that's been recycled. The simple steps that it goes through to end up as, I don't know, a chocolate bar wrapper or a toothpaste tube.
Yeah. So we'll do it for traditional fossil based plastics, and then we can talk about where things
Mm,
diverge with something new, solutions that are out there. But it starts with oil. So you drill oil out of the ground, and oil that thick black viscous liquid. Basically, lots of different chemicals in there. We call them
mm,
hydrocarbons because it's literally molecules made of hydrogen and carbon And the beautiful thing about carbon is it can form lots of chains. And sometimes those chains are straight, sometimes they've got branches, sometimes they're in rings. But basically, you extract oil from the ground, lots of different hydrocarbons. So then the first step that happens is you've got to separate the different hydrocarbons into different, what we call fractions. And some fractions are ready to use right now. So octane, you take octane, and that actually is effectively, Americans call it gasoline. It's the fuel that you use to power your car. That's quite a valuable fraction. There's lots of others fractions. So the heavier ones, the thicker oils, they might go into fuels like diesel. Some of the lighter fractions, so propane, for example, you separate that out, and that becomes the gas that you use to run a gas heater or a gas fire, a camping fire, and other uses. So you get a whole range of different materials. And what you do with those is, depending on the petroleum, sometimes you can get oil called naphtha, which is then used as kind of a basic feedstock, the material that then you can make other materials from. Sometimes you can get other fractions like ethane. I'm going to stick with ethane a little bit because it's a little bit easier to visualize. Because if you can extract ethane from the petroleum, and sometimes you do it by this kind of fractionation process that I talk about. Sometimes what you do is you take a longer carbon chain and you crack it, physically call it cracking. So you get big industrial kind of refineries that crack long molecules into smaller units. And one of the smallest units that you can make using hydrogen is ethane, which is basically two carbons back to back with surrounded by hydrogens, two carbons, six hydrogens. If you take ethane and you modify it and put it under high pressure, what you end up doing is you force the ethane molecules to kind of come together to form the two carbons come together with another two carbons to form four carbons. The four carbons come together with another four to form eight. What you're basically having is polymerization. You're taking a monomer, ethane, single molecule, combining it with lots of other ethanes in a chain to make a polymer, polyethylene. That's what the scientists at ICI in 1933 have discovered. They'd taken ethylene, which is a modified version of ethane, put it under high pressure, and they had a little bit of metal in the system, which acted as what we call a catalyst. And they basically found that they could form a long, long chain of this material, which to them just looked like wax. Now, today, what you get is you take that kind of waxy material and you form it into little pellets. And those pellets basically become the building block for making all your other types of packaging, because you take your pellets, you then moving all the way along, you're moving from the oil rig to the oil refinery to the plastics processor. But it basically, a plastics process company will then buy the pellets of polyethylene, and they'll melt them. So they'll heat them out until they'll melt. They'll put them inside a mold, and then keep the mold, pressed against the plastic for, these things run pretty quick now. You can make 300 a minute, but you basically you melt a plastic, you put it inside the mold, you separate the mold, and what you get out of it is a plastic component. That can be a bottle, it can be a thin sheet of plastic like a laminate, and that's effectively the end step in the process. So you go from the oil, you either fractionate it or you crack it, you polymerize it into something like polyethylene. You go then you turn it into little pellets. The little pellets then get either melted and rolled into sheets for laminate, or get melted or molded into plastic components, or made into any other, drawn out into fibers. So if you're making clothes, you can draw out the little pellets into long fibers, which then you can weave and you can make it into clothes and other textiles. But that's really the kind of process, super truncated, very overly simplified.
Yeah, and I think you've done really well there to take us through that, because yes, it gets much more complicated than that. But I think, for people to really understand that, as you said, in the sort of fossil fuel driven plastics, we can get onto some different versions of that. It does start from oil, and the oil that and why the oil industry is so big and so valuable, that you go from this thick black viscous material, but that's no good to anyone until you extract the different types from it. So fractionation, and anyone that's listened to our lemongrass oil or mint oil, they fractionate those oils as well, very different. But essentially, science goes through and separates the different components of that and takes it off for different things, whether it's, as you said there, petroleum for the car, or in this case, maybe naphtha or other things that go into making plastic. So really, really fascinating to hear that, and for people to understand that plastics do start traditionally fossil fuel driven from oil, which is why, when people talk about the oil price, it's not just going to affect the price at the pump. There can be impacts on your plastics, your packaging, many, many different supply chains. So yeah, really, really fascinating to understand that. Joe, you touched on there, obviously the traditional method. It would be great to hear what other plastics are there that we're starting to see, because, that is as a starting point from oil. Of course, I think we should later on get on to the point around recycling, the challenges with that and the infrastructure. But what different types of plastics are there and starting that we see being used?
So effectively, what you can do with plastics, you need to start with a feedstock. You need to start with a molecule that you're then going to polymerize. You're then going to join up with itself to form long, long chains. And that molecule traditionally comes from oil. There's lots of it, but you can take other base materials to start with. It's almost like baking a cake. You can start from slightly different ingredients to get to the same endpoint. And I'll oversimplify a little bit, but a lot of us are familiar with alcohol. So you take a sugar-based material, you can ferment it, and you form alcohol. Now, alcohol is quite similar to ethane. It's got two carbon atoms around it. It's got three hydrogens around one carbon. On the second carbon, what it has is hydrogen, and an OH molecule, an oxygen and hydrogen. That oxygen, hydrogen is basically an alcohol group. So the only difference between ethane and ethanol, the chemical name for alcohol, is that oxygen atom that forms an. So if you imagine then making ethanol, lots and lots of ethanol, and you've got a molecule that's very, very similar to ethane, you can do a chemical process, dehydrogenation, where you basically strip out the group, you replace it with a hydrogen. Now you're back to ethane. Now you can do the conversion of ethane to ethene, then you can polymerize it, and then you can make it back up to the same material before. It's exactly the same material. All you've done is you started with ethanol that's been grown from plants, and you've done a little bit of cookery on the molecule to modify it to make it. And that's a significant new form of material that started to come online recently. Now, the example I came is really overly simplified. I mean, I've talked about how you can make it from sugarcane to make sugar to ferment it into alcohol. You can also do a similar thing where you take out other waste food products, what we call biomass. So leftovers from the food manufacturing process, things like corn husks and other materials that we don't eat, but they still contain carbon chains, carbon materials that you can do chemistry on. Sometimes you ferment them into alcohol, sometimes you turn them into other molecules that are similar to ethane, and then you do the chemistry to turn them into ethene and all the other types of materials that you get. But you've got to start off with something. And the chemistry has been around for a while, but there are challenges here that we need to kind of work through a little bit, because the simple example I've described, which is, grow lots of sugar, make the sugar into alcohol. Well, okay, but now you've got to have land to grow the sugar. So do you need a forest to grow this? What's that doing in terms of your carbon? Are you now getting to the stage where people are going to be more compelled to grow plants for fuel and for plastics instead of feeding people? Ethical questions need to come into play. And what's happened here is, when it was first done, people started off with sugar. Then progressively, people have said, how do we use what we call second generation biomass, which is just leftovers from other processes. So you take out the valuable, the corn, what you're left with is the husks. How do you process that to make the feedstock? So there's been a lot more of that happening lately. And the benefit of that is you're not bringing any more carbon into the atmosphere. So with a fossil fuel, you've got all of this carbon that's been locked up from these ancient forests from millions of years ago, but basically formed into coal or gas, and you're releasing that into the atmosphere. So you're basically taking stuff that's been buried and releasing it. Well,
Mm,
if you're using biomass to make plastic, the plants are basically sucking up carbon dioxide using photosynthesis to make more of the plant material. So
mm,
the amount of carbon dioxide in the atmosphere is constant. You're not creating any more, you're not
yeah.
removing any, it's constant. So that's one of the benefits of those materials. And the more what we can do of them, the more we can use kind of biomass conversion into making feedstocks for plastics or for other chemicals, then the less reliant we are on driving fossil fuels.
Yeah, so interesting. And Joe, from a consumer's point of view, and probably, speaking from our viewers and listeners' viewpoint, would they have seen this as, would these be described as plant-based plastics? I know sometimes on packaging, people talk about, I don't know whether, I'm sure I've maybe seen it on Coca-Cola bottles where they've talked about this is made from plant-based plastics. That's what it's talking about, but
Yeah,
it's not
typically.
specific to it. It can come from any different plant, as you said there, sugar cane maybe, or corn husks, or anything that essentially has this chemical makeup that can eventually be made into exactly the same plastic as what you derived originally from crude oil.
Yeah, waste vegetable oil as well. So yeah, they're identical. I mean, so they're completely indistinguishable, depending on the type of product. And so some manufacturers might make claims and they'll say plant based plastic, and often that's typically what they would mean. It would just mean that a certain amount of this plastic started off life as a plant.
Mm,
Now, there are some other types of plastics called which are basically also plant derived, but which can be have different chemical properties to plastic. They're different forms. They're not like polyethylene or polypropylene. They have different chemical structures, different materials. Some of them are designed to biodegrade.
mm,
They are the terminology is a little bit loose. Some people call them bioplastics. Others call them biopolymers. I mean, I prefer biopolymer version, but you might hear of materials like PLA, polylactates, about where these have been new plastics that have been developed to try and address some of the issues that we currently see with things like polyethylene and polypropylene. They're designed to biodegrade and so on. And they have a role, but they also have their own challenges because they can contaminate recycling streams, and their properties are not necessarily as useful as the plastics that we've been using for the last century or so. But to a consumer, when you buy, well, here's a little plug. If you buy a Sensodyne toothpaste tube, the cap on the toothpaste tube is made out of bioresin. It's made out of bioplastic, and
ah,
that's been derived from plants, and you can't tell the difference. It's completely indistinguishable.
mm, fantastic. Yeah, really good to know. So it's not just the tube that's been made recycled. Then there's been some innovation on the cap as well to be made from a bio-based plastic.
Yeah, the tube has been made so that it can be recycled. The cap has been made out of just a non-fossil based plastic.
Wow, really interesting. Really, really interesting. Yeah, and fantastic to see that innovation that's going into the market. And as you said there, the benefits of those plant-based plastics as well is that, from a carbon perspective, because there's a big carbon footprint, of course, anything that derives back from oil, oil is, and the fossil fuel industry is, of course, a big emitter because you're releasing those carbons that have been stored for so long into the atmosphere, depending on what you're using them. It's moving away from that. But yeah, interesting to see how the industry is developing there. I think it would be good now to, we've obviously touched on the fact that the tube now, fantastic to know that the toothpaste tubes and most toothpaste tubes are getting to the point that they're going to be in a recyclable format. Let's talk about recyclability, and specifically on the toothpaste tube. It would be great to understand what is the process of recycling, and you know, I guess the question is, if something's recyclable, is it always recycled?
Yeah, I mean that's a good question. So if we start off with the way the whole kind of process is designed to work, I mean, we packaging manufacturers work with the waste industry to try and understand what can the waste industry handle, what can they process, and what can we design. And there's always a little bit of tension here, because if you're making a branded product, you want it to look as different as possible from everyone else's. You want it to have nice colors, nice printing, interesting shapes,
Mm,
different sizes, all of that sort of stuff, and actually potentially made of different plastics because you're using different materials. If you're a recycler, what you want is the same. You want everything to have the same
Yeah.
shape, the same material, the same size, the same everything, because it means you've got to deal with less. It's less hassle, it's less effort on your side to be able to process it. So there's always that little bit of tension. But effectively, we end up with standards that say, look, if I can design a product in this way, then it's going to run down the line. With tubes, we started to do some of this with the recycling industry. We actually started to understand, what can you not handle? Well, we can't handle composite laminates. We can't handle the aluminium. Okay, so let's take the aluminium out. So then we started to develop these tubes made out of one type of plastic. So one of the first things that we did with a recycling industry was to physically do trials. We would take hundreds and hundreds of tubes, put them in down a recycling line, and check that the recycling plant can actually sort the tubes into tubes for them to then be processed later. So we did a lot of that, first of all, tubes, then with tubes mingled with other types of waste, just to check that they can be recycled. And we were able to get that validation. So we knew the recycling plant could handle it. So then you start filling in the rest of the pieces around the jigsaw puzzles. Then you start to look at, well, how do we educate consumers to be able to put the tubes in the recycling bin? The bin then gets collected by your local authority in the UK. It varies country by country, but it gets collected by someone. In the UK, it's not normally a council, who then take it to a what we call a MRF, materials reclamation facility or materials recycling facility. There's a bit of ambiguity around the acronym, which basically then sorts out the stuff that's in your bin into all the different types of materials. So a lot of householders, that we don't separate plastics from glass, from metal, from paper. Some councils do, some don't. Then that situation is changing in the UK, but for a lot of places, you're still having what we call commingled waste. So the MRF takes it and separates, strips out the paper first, then things run through a magnet, and steel gets picked up by the magnet. There's an anti-magnet called an eddy current that basically pops out the aluminium. So you're separating, the paper, the metal, the glass. You come to the plastics, and this is where the bit I described around tubes, all the plastic comes along. And because we've tested the tubes down the line and it can separate, the tubes will separate and they'll go with other types of HDPE. The way that all the different types of plastics get separated, there's lots of different techniques. But one of the most common ones is called flotation. And what you do with this is literally you take a plastic, you shred it into small pieces, you put it in a vat of water. Certain types of plastics like polypropylene, polyethylene, they float. They are less dense than water, so they float on the top. Other types of plastic like polyethylene terephthalate, PET, the plastic that's used to make drinks bottles, it's heavier than water, so that sinks. So now you're separating the different types of plastics. You take the material, whether it's polyethylene or PET, and that shredded material then gets washed a little bit more. Sometimes you might use surfactants or cleansing material, soaps, to kind of clean it. And then it gets stored into basically bales of material that go to a recycling plant. And what the recycling plant then does is it takes these little fragments, chips of plastic, and it melts them down. It melts them back into liquid plastic. Then they'll run through, depending on what you're doing with it, what we call a little extruder. So it's almost like a thin nozzle that basically produces like a thin noodle of plastic. That thin noodle of plastic, as it flows out, then gets chopped up into lots of individual bits, which become pellets. Those pellets then get put into big 1-ton bags. Those bags then go to the manufacturer that's going to make a plastic bottle. They get melted back down, put into a mold, made back into a plastic bottle. Sometimes it's all just recycled pellets. Sometimes there's a mixture of recycled and virgin and everything in between. And that's the separation piece. Again, I've got a simplified. So the easy one is PET from polypropylene and polyethylene, because you've got a difference in the density. One floats, two of those plastics float, the other one doesn't. There's other separations that happen in there. Sometimes you might use an optical camera, an infrared camera that can detect different types of plastics. So it can be separated that way. But fundamentally, if you take the process back to the heart, you strip out metals, plastics, glass, you separate the different kinds of plastics, you wash the plastic, melt it, turn it back into pellets, and feed it back into a train.
Wow.
That's one type of recycling called mechanical
Hmm.
recycling. That's the most common one.
Yeah.
Yeah. And what you do with that one is you're basically shredding and remelting the plastic.
Yeah. Yeah.
Again, science moves on a little bit, because what happens with that type of recycling is every time you wash a plastic, you recycle plastic, and you separate it all out, you don't quite get 100% separation. You still get other types of material called contaminants. And
Hmm.
then when you remelt it, you don't quite remelt it and reform it in as perfect a structure as it was before. That long carbon chain that is there when you make it the first time around starts to get broken down. It starts to get little impurities in the carbon chain. The chain lengths change. All these little things, plus the impurities, that mean that you degrade the plastic a little bit. So every time you then subsequently recycle it mechanically, you're degrading it a little bit and a little bit and a little bit. And that's where you hear people say, well, you can recycle plastic 7 times. Well, it
Mm.
depends on the plastic. It depends on how clean the stream is, but basically you're degrading it. What we've done in the last decade is, well, the science has been around for a long time now, but what's starting to happen a lot more of now is what we call advanced recycling processes. And these are methods where you can take a waste plastic material and you basically break it back down into the oil. So instead of chopping it up into little pieces and remelting it, you turn it back into oil. When it's
Mm.
oil, it's much easier to purify. You could put it back into the chemical cracker or the chemical refinery, and you could basically produce a new plastic that's completely indistinguishable to the petrochemically derived virgin plastic. That type of recycling has got a few names: advanced recycling, chemically recycled plastic, but it's a bit more complex, but it allows you to break it right back to oil, or in some cases back to the original feedstock molecule. So you
Mm.
basically have a completely virgin-like material, but made from recycled plastic.
Wow. Wow. So fascinating. So you've got mechanically recycled, the, one as you described there, which is sorting, out of your recycling bin, take the paper down one route, take the metal down another route, but specifically on plastics, then start to chop it up and remelt it, as you said. But then this chemically recycled route is getting that plastic, but literally taking it back into its chemical
Yeah,
form, and then
yeah.
goes back into that same supply chain that you described at the start, the sort of virgin one essentially, but it's just that the feedstock has come in from a recycled route, which is fantastic. Yeah, so interesting. So interesting. Question, you talked earlier about recycling rates. Also, I imagine each market has a very different recycling infrastructure, whether it's the UK versus the US versus Germany versus, I don't know, Thailand, other places. What challenges and impacts is the recycling industry going through and seeing at the moment?
I think a lot of it boils down to money. It costs money to be able to run a kind of recycling infrastructure, um, and the money is driven by how valuable is the thing that you're trying to recycle. So,
Mm.
I remember being at a plastics conference once. Somebody said, "Well, our £5 notes are made of plastic. You don't get any plastic pollution because of £5 notes because they're valuable." So,
Mm.
anyway, so if you kind of extrapolate from that a little bit, in the UK, you pay your council tax. Your council tax funds a whole lot of services, and that then basically gets used to run your waste collection, waste disposal, waste recycling. Now, if you're running a recycling plant, you want to basically recycle as much of your valuable stuff as you can. You want as little um, impact on your line. If you're dealing with very dirty plastics, lots of different types of materials mixed together, not very pure, contaminated with leftovers of products or foods or other stuff that were originally packaged, um, it reduces the quality and it reduces the speed. So if you're a recycler, you want to run your lines as quickly as you possibly can. You want the stuff that you produce at the end of your line to be as pure as possible. The more variation you have, the more contamination you have, the slower your lines are going to be and the lower the quality of your material. So the lower the price that you're going to get. So the less money you make, so the less you can reinvest. So that's the sort of challenge that you get. And it's kind of economies of scale. The more that you do it, the more you can reinvest, the more you can put better technology, the more you can improve the quality, and the more money you can feed back in. That's why you see governments bringing in place things like plastic taxes and what we call extended producer responsibility schemes, which are all about getting the producers to basically contribute towards the cost of collecting, sorting, and recycling
Mm.
plastic. So it's a very
Mm.
small. on every plastic component, packaging component, but then basically goes towards funding its collection and recycling. There's
Yeah.
lots of discussions around, is that money, is there enough to pay for it? Is it too high? Is it putting a burden? I don't really want to get into it because it's a big nuanced argument, but fundamentally, we're putting material out there and suppliers, producers, brand owners, companies that make the packaging pay a little bit towards it.
Mm.
Now, that again depends a little bit on how the systems have been set up, how mature the market is, and how bothered are consumers about doing this extra piece of work to separate the materials, put recycling in the recycle bin or not. And some places in Europe, Germany, France, Italy, Scandinavian countries, they take a lot of this stuff quite seriously. They've been doing it for a long time. It's quite ingrained. They talk a lot about, doing things for the kind of wider society. So the norm is much more around how do you recycle your materials.
Mm.
Other markets like the US, much less so. It's not been as an ingrained behavior to kind of recycle everything that you use as it has been in other markets.
Mm.
The UK, as in so many other places, we're kind of somewhere in the middle. So
Yeah.
yes, we understand it, but perhaps not as much as the European countries. So that's what kind of drives the money in what we call developed markets. So the richer countries where
Mm.
you can put in place the money to be able to build in a recycling plant, have lorries that collect your waste and your materials to be recycled, and you drive it. Most of the world, though, don't live in that environment. And if you go to poorer countries, developing markets, developing countries, they don't have lorry bins coming outside your house collecting your blue bin or your green bin or your black bin or your whatever. It's much more what we call informal in there, where people may, they put the rubbish outside, and there's informal collectors that collect the material, and they get paid by the householders, or people dump it on the street, or it ends up in in big tips where people dump it. And in those sorts of markets, you get all sorts of different schemes. Many of them what we call informal, where people will go out there and they'll start picking litter.
Mm.
And I've seen people do this on the street in India, where you get kids that will go out there and they'll pick plastic bottles off the street, collect lots of them together, sell it onto somebody who then aggregates them, sells them on, and they make money out of that. They and So I've seen people do it in the street. I've seen people do it in rubbish tips, where they'll go through a rubbish tip and they'll pick out the valuable stuff. Always metals
Mm.
first, but then
Mm.
different types of plastics, and they'll collect them. So again, in those sorts of places, the money isn't there, but the material still has a value. So they collect it, they aggregate it up, and they sell it on. And there are companies out there, organizations out there that try and find a way to be able to say, look, people need to make a living. That's a way that they can make a living. How do we make it safer for them to be able to collect those materials, to give them gloves, make sure they've got footwear, make sure that they understand what's safe and what isn't. So how do they provide the facilities to be able to do that? And how do they pay people a fair wage for material that they're collecting, they're recycling?
Mm.
And there are organizations out there that will do this. I mean, I worked with a company called We Cyclers in Nigeria. In my previous job in Unilever, I was doing precisely this. They'd have guys going around on bicycles who would collect people's rubbish or the material that could be recycled, and they would take it to an aggregation facility, and then they would recycle it up. Not only would they provide, a lot of these organizations, what we call them social enterprises, but what we typically do is that not only provide safety gear, but also do other things like check that, you haven't got kids working on there, because
Mm.
when all of this is informal, you do get stuff happening where, very young kids end up having to scavenge and look for materials to try and make money to be able to fund their family. So even with the informal sector, having little mechanisms in there, little ways of being able to fund some of these social enterprises so that they can provide education, they can provide a fair price, they can provide safety equipment, they can make sure that kids aren't doing this and kids are actually in school. You can start to get plastics and other packaging getting collected in markets where there isn't a formalized government or council run way of recycling. And that's
Mm.
the challenge. So a lot of the solutions that we talk about, they're designed in your mind. You're thinking Europe, you're thinking North America, you're thinking Japan, Australia. There is a massive informal sector that operates in Africa, in South Asia, like India, big parts of China, big parts of Latin America, where that infrastructure isn't there. And people are like, and
Mm.
it's countries where you had a bit of both. So
Yeah.
China, they do have waste bins, but also they have an informal collection. So it's really trying to find a way of taking something that, is messy, and
Mm.
trying to find ways so that people can make money out of it to make it sustainable as a business, but also doing it in a safe way, so that, we can provide materials in a more sustainable way.
Yeah, it's so fascinating. And, just for people to understand, maybe if they're listening from the UK or wherever they're listening to this podcast from, it's going to be very different in their market. As you described there, you see in the UK that we have, curbside collection of our waste and our recycling that then gets taken away. And yes, our council tax, as well as the responsibility of producers investing in industry, goes into producing that. I've seen on trips to Vancouver in Canada where actually, I went to buy some beers and a bottle of wine from the off license, and on my receipt it described to me the value in dollars of the aluminium in the cans and the glass. And therefore you see queues of people outside recycling stations because as they put their bottles and their cans back in to recycle, they get that money back. They get dollars back in their pocket. That's another sort of incentive. And then, as you described there, I've seen in my trips to India, the amount of waste that you see on the side of the roads and in various places because they don't have that infrastructure in place, especially in some of the very rural areas. But then you get this informal waste picking as well that I know a lot of companies, you say you've got examples from Unilever. I know, people like PepsiCo, Tetra Pak have got examples of where they're starting to use and invest and support the sort of informal waste picking to bring back into their supply chain. So very different per market, but and a long way to go, I would say. But fantastic that some work's being done there. And like we go back to, plastics are fantastic and what they provide for us, but it needs that end of life to be fully in place to realize the benefits right the way through the supply chain.
Yeah, and it's messy. I mean, that transition is complex, and I think it's money drives a lot of it. Well, it drives all of it in the end. I mean, that's why plastics became so ubiquitous. There was a way of being able to provide goods, products, foods to people who couldn't previously access them. So, they provided an enormous uplift in the quality of life for people.
Mm,
Then with that came unintended consequences that people just didn't think about. And trying to find a kind of cookie cutter, here's the answer everywhere. That's just not going to
mm,
work. You talked
yeah.
about deposit schemes. I mean, we're bringing a deposit scheme in the UK, deposit return scheme, DRS. Years ago, you'd get a deposit on your Coke bottle or your beer bottle,
Mhm,
and that kind of completely died. Actually, a lot of countries, like especially the Nordics, but some states in the US, other countries in Europe, they've been bringing in schemes where there is a deposit on your beer bottle, on your Coke bottle, on your whatever bottle, and so you bring it back and you get some of that money back. So maybe that's some way of doing it, but all of this rubs up against life. If you're busy and you're chasing after the kids, and if the amount of deposit that you get back is, a tenth of a penny, are you going to bother? Um, if you make it really expensive and you say there's a £5 deposit on every can of Coke, then all of a sudden, yeah, you're going to collect every single one of it, but you're going to stop people from being able to afford them. So it's that balance between how much can you put onto the cost to make it sufficient for people to bother doing it, but also not price people out. You would
mm,
know from our time in Halion that access to healthcare, access to medicine is massively important. So whatever we can do,
mm,
putting on unnecessary costs onto our products to make them affordable for people is a good thing. So how do we do that whilst at the same time trying to provide funding, money to be able to drive a recycling? There isn't we're still figuring that out, and the answer keeps changing depending on what's happening in the external world, and it's different in different
mm,
markets. But we are moving. I don't
mm,
believe that the future doesn't. There isn't a future in my mind without plastics. I mean, I sound like a bit of an advocate for plastics. I mean, I come at this as a scientist. If you want to reduce carbon, you've got to be using plastics,
yeah.
but you've also got to be putting in place the right mechanisms to do something with them at the end. That isn't landfilling. That isn't dumping them in the ocean. You've got to be recycling them. You've got to be reusing them.
Yeah. Absolutely. I fully agree. I fully agree. Joe, we could keep chatting, I think, for hours and hours because it's such a fascinating topic and so many different avenues we could go down because we've really broadened to packaging there. But for people listening, should they put their toothpaste tubes into their recycling bin? Simple one.
In the UK, most councils will accept it. The best thing to do is to check the Recycle Now website to double check if your council will accept toothpaste tubes. But About a third of them are already doing it. The remaining councils are busy updating their websites to collect tubes.
Fantastic. So always check, but it sounds as though probably pretty worth doing, and great to know that they are now, as you've described very well, mainly recyclable, which has been a fantastic move. Joe, it's been a fantastic conversation. Like I say, I think we could have gone for hours and hours, but yeah, the fact that you've taken us through how plastics are made, the different new forms of plastics, how a toothpaste tube is formed, the history of it and how it's now in a recyclable form, and the conversation I think we've had about the recycling industry is truly, truly fascinating. And I've really enjoyed it, and I hope people at home have as well. Final thing before we close, anything that we haven't touched on that would be worth mentioning to people?
We've talked about a lot, but I think, look, this is a big, hairy topic. It's scary when you think about the scale of it, but actually it all starts with taking small actions. So thinking about what you can do in your day-to-day life. If you're seeing something out about just looks overpackaged, why are you getting it? If you're buying something, do you really need it? The single biggest thing to actually solve a lot of the challenges we've got, it's not really about recycling or lower carbon. So it's just use what you need. So we joked a little bit about disposable fashion at the start, but actually thinking about, consumption. Do we really need all this stuff? And then when we are buying something, just taking a step to think about, that product. Am I making a choice here that I know do I know what to do with it, at the end of its life? And if I don't, maybe pause and think, because if there's one next to it, but I do know what to do with it, maybe go with that one. But just thinking about the little steps in your life.
Yeah. Yeah, and a fantastic thing to leave us on, especially as we have just seen Thanksgiving, Black Friday, and we're coming up to the Christmas holidays, where overconsumption is potentially rife. So I think a great thing to leave people on. Joe, thank you so much. It's been a fantastic conversation. I really appreciate it. It was fantastic to work with you as well. And I know that we'll stay well in touch. And I'm interested and intrigued to hear what your next move is, which I know you're going to announce in a few weeks, as you said. But take care of yourself, and let's speak again soon.
Thank you, Ben. It's a pleasure.